Good afternoon, ladies and gentlemen of Precalculus. What we're going to be doing is using sign charts on exercise 7 through 12. But prior to that, I want to go ahead and analyze 6 just with sign charts alone. And so what you do is you look for the zeros and their multiplicities. Well, here we have x is equal to -2. And since we have a cubed here, that's a multiplicity of 3. And then we have, for this factor right here, we don't have any real zeros possible out of there, right?
Right.
And then we have x is equal to 9 is our zero related to this, and multiplicity is equal to 4. And so the way the sign chart works out is, well, what you'll do first is figure out what's going on here with the cubes. So we got x cubed times 4x squared, which is going to be 4x to the 5th, right? Times x to the 4th, so that's going to be 4x to the 9th.
Oh, that's not the one I want.
Right?
Yep.
That's going to be our leading term. And now now the sign chart here, we put -2 and 9, right? And we know since we have this thing here, what's going to be the end behavior of this?
Even odd.
It's odd and positive, right? So starts low, ends high. So that means that if we come from the left, starting low, this first interval we see is going to be negative. And then we get to -2, and what's the multiplicity here? 3, right? So is that going to cross or going to stay on the same side of the x-axis? It'll cross. So we switch signs because this is odd, right? And then we get to 9, and so we're going to go touch the x-axis again. But what's going to happen? Are we going to touch or cross the x-axis? We're going to touch because of that. And so the sign chart is going to give us this kind of plus or minus. And so now we can answer this question is, well, we have the zeros at x equals -2 and x equals 9. Those will be our zeros. Next, we have positive. We know we're positive right here starting at -2. So, for greater than -2, excuse me. So we got -2 all the way up to 9. And then 9, that's union, 9, comma infinity. So that's where it's positive. And where's the thing negative? Well,
Yes.
just this one. Negative infinity to 2.
-2.
To -2, thank you. And so that's going to be our sign chart analysis, and then graphically the thing would look like this. The thing would come up like this, be positive here, come down to 9, touch the x-axis and go up like that, right? And when you graph that, and we went over that. So now we come to problem 7. And for problem 7, what I can do for this one is just work this one out, or I can call on somebody to work it out. You want me to work it out?
Let's work it out.
Can you work it out, the first one for us?
Yeah, the first one I will, okay? Well, it's really similar to what number 6 was. And some of these we're going to have, it says complete the factoring if needed. In this case, we're already in factored form, so it's not needed, right? So here we have x is equal to -1 is one of our zeros, and the multiplicity of that zero is 1. Yeah, and then greater than. And also we have x equals 3, and for this zero, the multiplicity is equal to 2 because of the squared, right? And what we're doing is we're pretending like we have this function, like the function's f of x is equal to x plus 1 times quantity x minus 3 squared. So it's like we're graphing that function and seeing where that function is greater than 0, or where the graph of this is greater than 0. So when we multiply all the x's together for this, what do we have? It's going to be x to what power?
X to the third.
X to the third. Is that going to be positive?
That's good.
Yeah, positive, right?
Okay.
So the third power does what? Starts low, ends high. And so now, where do we mark the zeros? At -1 and at 3. And so we're starting low, so our first interval is negative. And then at -1, is that an odd number or even numbered multiplicity?
That is odd.
Odd. So are we going to have a change of signs here?
Yes.
Yes. And then at 3, we come to 3, is that even or odd number multiplicity? Are we going to change signs?
No.
No, we're not. And so we're asked, where is this greater than? And so we see that right in front of us here on the sign chart, don't we? And so I'm going to make a conclusion statement here. On the x plus 1, x minus 3 squared is greater than 0 on the interval of -1 to 3. And this is actually not an equal to, right? There's not an equal to there. So we're going to have a break, aren't we? And did anybody graph that in the calculator?
No.
If you did, that's part of the thing. So support graphically. Well, support graphically is when we graph the thing, it's going to look like this, right? X plus 1, x minus 3 squared. I'm going to do that right here. So x plus 1, x minus 3 squared. So we graph, we see exactly what we talked about, right? Greater than from -1 to 3, 0 at 3, and greater than again for greater than 3. All right? Okay. That being the case, I'll have you go ahead and work number 8, and I'm going to choose a victim to work out number 8 for us here. How's that?
Give it to him with death penalty.
Pardon me?
Give it to him with death penalty.
The death penalty?
Yeah.
Okay. Okay. Well, I didn't.
Death penalty, I'll take it.
All right.
Well, it depends on what we're around.
Okay. Let's go ahead here. So did you finish number 8 yet? You're working on it? We got a couple left-handers working on number. Now, Jane, did you watch the video I sent out yesterday too? Okay, so this is not totally unfamiliar to you. Good. And we have a lot of students out here from this class. I don't know if you heard about that. Okay. So I hope they're watching. Let's see. Yes, 4 thirds.
So we'll go with this though?
Yeah, that's it.
So this is right.
Yeah, that's it. Yeah, that's it. And then you have your, let me see here. Yeah, that should be it. I think that's it. No, it should be less than, excuse me. I think you might have it backwards. Because what it is, you can have, you put for greater than. So less than is going to be the other, it's going to be negative infinity to that, and then this thing between 4/3 and 2. So you just got it backwards. And then there's another thing. Okay, let me go ahead. So you guys are doing pretty well. Let me pick somebody for this. Open. 6th period. Those of us who are left, most of us are gone today.
It's gonna be Caleb.
It better not be.
Kenzie. Yeah, Kenzie or Emma.
I believe Will should go because he's Emma's closest friend.
I'm not sure about that one.
You know, I'll go if it isn't me.
Emily, and she's on here.
It's just getting closer and closer to my name now.
Yeah.
If one person,
Well, I could shuffle it here, kind of.
Well, don't do that. It might choose me now.
That's the way it works.
okay.
Okay, it's going to be Will. Woo!
All right, well,
Every surgery in the living versus plastic surgery.
What?
Every surgery in the living versus plastic surgery.
all right, Will, what do you got, Will?
I got for the leading exponent is 6x cubed. And then the zeros are x equals negative 1/2. Then x equals 2. And then x equals 4/3.
Okay, that's what Kayla and Jana got. All right, what next?
And then on the line sign chart, plot those zeros out.
And the zeros are?
Negative 1/2, 4/3, and 2.
Okay,
And so it's going to be negative, and then positive, and negative, and positive.
and so you're saying multiplicity of all these is 1?
Yes.
Okay, and then ready to make your concluding statement? On what intervals? Are we negative or less than?
Less than negative infinity to negative 1/2. And then
Parentheses or bracket?
Bracket.
It's
bracket.
bracket.
Equal to.
Okay, got that? Good job, Kayla. All right. What next?
And then the union, and then negative 4/3 to the 2.
4/3 to 2?
Yep.
Bracket 2?
Yep.
Okay, and then what does the graph of the thing look like?
Just gonna go up and down, and back up.
Okay. So this will be our answer here.
So it looks like the back of the car that you drove in was.
What, this here?
Yeah.
Okay, yeah. All right, good job, and I appreciate Kayla picking up the bracket. That's really good work. Good work. Okay, go on to 9. How about Carmen, were you okay on that? Now here, it says complete the factoring if needed. Here, is this thing totally factored?
No.
No, it's not. So it gives you another layer of degree of difficulty, if that's what you want to call it. zeros. Then you know how to factor that. Okay, and you'll be able to get the rest.
Mr. J, will you come look at this?
Yeah, I'll look at it. Let's see, 1, 2. I just had to think of it first.
So we have to look up.
Should be negative 1, 1, 2.
Yep. There it is.
Oh, I put the wrong thing down.
But then if you're otherwise, what you said is right. Okay. All right, so now we get someone else to get involved here. See, shuffle this. Let's go ahead.
Oh, yeah.
Kayla, all right, Kayla, good job. It's kind of not fair because Kayla has it already easy. That's all right. We'll go with it. It is what it is. All right, what do we got, Kayla?
The zeros are x minus 1, x equals negative 1, x equals 1, and 2.
And typically this next one is one.
They're all the multiplicity of 1.
Okay. All right, good.
On the little chart, it'll be negative, positive, negative, and positive.
So you're saying negative, positive, negative, positive? Okay, and then, so if we make our concluding statement, is less than 0 on what intervals?
Negative infinity and negative 1. Union,
Is that going to be parentheses or bracket?
parentheses,
Parentheses, okay, union.
and from 1 and to 10.
That's supposed to be negative 1, okay. Yeah, 1 to 2. Okay. Now, one thing she didn't tell us, but you kind of would assume here, is the factored form of this thing here, this quadratic trinomial. She got x minus 1, x minus 2. Is that what you got for that?
Yes.
And so here's where 1 and 2 come from for zeros. Okay? All right, good work. I'll give you credit for that. Let's get on to number 10. Okay. Number 10. Okay, these things here.
Thank you.
Well, I should work.
No, it's that's it.
Mr. G, you want to do one?
Yeah.
No, Will isn't allowed to have stickers.
No, yes.
No, okay.
Not since the last incident.
Well,
Leave that.
yes, you can remind me about stickers. I can do that. Here, thanks. Thanks for reminding me.
Mr. G, will you come look at the
Okay. I'm just looking at it first to make sure I understand what's going on.
this? Would this just be a multiplicity of 2 circles?
I think the 0, that's not exactly right.
What,
Not in the
maybe?
right place. No, that's not right. That's the right one, but it's not in the right place. One
Oh,
is-
that's, I see what you're saying. Okay.
I think, yeah.
700, yeah.
Yeah.
But, on this, would it be a multiplicity of 2 since it's the same way twice? 2.
Right, yeah.
So would it be like,
That's multiplicity 2, so
oh,
minus, so we can minus here. Doesn't change. 'Cause that's multiplicity 2, right?
minus and then change.
Yeah.
Okay, so it'll be like this.
Right.
Okay. Thank you.
Yeah, that's it. Okay.
This one?
One load unit problem.
Huh?
One load
The
unit
only
problem.
thing is you got 7 over 2 is supposed to go over here.
Oh,
Right. There we go, okay, that looks good. Our color, that looks good. All right, I'll call somebody. Okay, here we go. I'm gonna get Adam, all right, Adam.
come on.
Attaboy, Adam.
I'll do it for you.
All right.
I'm doing it for Adam.
Right, Adam, what do we got?
The zeros are x. Yeah, I'm taking them off.
Okay,
The zeros are 7 over 2 and 2 with multiple. 2 is a multiplicity of 2.
okay, so this one here is multiplicity equals 1, and multiplicity equals 2. Okay,
It's a non-positive.
so odd positive, okay? Then what?
Well, you do a sign chart thing. It's a negative, negative on top.
Where are the numbers here? Where do they go?
2 and 7 and 2.
Okay, then what?
Like, it's a negative, negative and positive.
Okay, and so we're ready to make our statement here?
Yeah, 2x minus 7 is a little greater than 0 and 7 over 2 to infinity.
So, is that going to be parentheses or bracket?
Parentheses.
Okay? So is that going to be that one here? Now, what's going to happen on 11 and 12 is the factoring becomes a little more challenging because you're not given any factors to deal with. And so I want to tell you kind of the process, kind of do a shortcut for number 11. And then we'll finish by choosing somebody again for number 12. But right here, what happens, we get to rational roots theorem, and potential factors are going to be, rational roots are going to be plus or minus the factors of the last term. And what are your factors of 6 going to be?
3 and 2.
And 6 more.
So 1, 2, 3, 6, right? Over the factors of 2, what are your factors of 2?
1 and 2.
1 and 2. And so your list of potential rational zeros are going to be, let me just write here, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then 1 over 2, plus or minus 1 over 2, and then we have 2 over 2, which is already 1, right?
Yep.
Then 3 plus or minus 3 over 2, and then plus or minus 6 over 2, which is already 3. So this is our list of potential rational zeros. Now, what you can do is use the remainder theorem for this, and plug this in, and plug in a value to see if it makes this equal to 0. Then we know we have a real zero for this. And it's really easy to use 1, because for 1 you can just do it mentally. So if x is 1, you'll have 2 minus 3, which is negative 1, minus 11. So negative 1 minus 11 is negative 12, plus 6 is negative 6. So 1 is not a 0. And if you take negative 1, you'll get 2 times, you'll get negative 2 minus, what's that?
Wouldn't it just be 2 since you're cubing it?
No, it'll be negative 2, because 2 times negative 1 cubed, that's going to be equal to negative 2, right?
Yeah.
And this one here is going to be negative 3 times that, and then we would have negative here, so plus 11, plus 6, and that's not going to be equal to 0. So negative 1 is not a 0 either, okay? And if you plug in 2, you have 2 times 2 cubed minus 3 times 2 squared minus 11 times 2 plus 6. So we have, this is going to be 2 times 8, so 16 minus 12 minus 2, oh wait a second, minus 22, right? Plus 6, so that's going to be 4 minus 22, that's going to be negative 18 plus 6, so that's going to be negative 12, that's not going to be 0. So you try negative 2, so 2 times negative 2 cubed minus 3 times negative 2 squared minus 11 times negative 2 plus 6. And here you have
0.
Yeah, you're going to have 0 because you have negative 16 minus 12 plus 22 plus 6. So that's negative 28 plus 28 equals 0. So that means x equals negative 2 is a 0. And it also means that x plus 2 is a factor. Okay, how do you find the rest of them here? How do you find the rest of the zeros?
No, you can do this
You can synthetically divide, right? So negative 2, so you got 2, negative 3, negative 11, and 6. So you bring this down, we get 2. Negative 2 times 2 is negative 4. We get negative 7. And then we get 14 here, 3, negative 6. So we get 2x squared minus 7x plus 3. And what is that in factored form?
In factored form is
We know it's going to be negative, right? And we know one's going to be 2x, and one's going to be x, right? And so so the factors of 3 are just going to be
2x minus 1 and x minus 3.
2x minus 1, x minus 3. So the factoring, you don't have a lot of different possibilities, so that kind of makes it pretty easy. And so you have that is greater than or equal to 0. And so what are your real zeros here? Well, you already have x equals -2. We already knew that, right? Then you have x is equal to 1/2. Then you have x is equal to 3. And so now you can do your sign chart. So your sign chart is going to be -2, 1/2, and 3. And then that's going to be odd positive, right? So that's going to be negative. All these multiplicities are 1. Negative, positive, negative, positive. And you're greater than or equal to. So we say 2x cubed minus 3x squared minus 11x plus 6 is greater than or equal to 0 on this interval here from -2 to 1/2, and union here 3 greater than or equal to 3 less than infinity. Okay, so that's going to be our kind of our concluding statement. What was the hardest part of this one? Yeah, factoring, really. The first part, specifically finding the real zeros, right? As it turns out, 12 I think is easier because there are less possible rational zeros. You see that for 12? Because all you have is 1, 2, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That's all you have available, so it's gonna make your work easier. And I,
Two,
2 is one of them.
positive 2.
2, because we get 8 minus 12 plus 2 plus 6. So 2 would be one of them, right? Yeah. So go ahead and work. I'm going to choose somebody for this one. And we don't have very many victims left. We have Jana and Carmen.
Who's on stupid?
We got Jana. Jana, do you have this ready yet?
No.
She's working on it. We'll let Jana wrap it up for us today.
Yeah.
Okay, yeah. Yeah, I'll get you. Looks like we finished here. Okay. I don't know, let's see, let me see. Okay, I'm looking at Jana's paper here. And so these are the zeros that she got. She got x is equal to 1, you said, right? -1. X is equal to 2, and x is equal to 3. Is that what we got for this one?
Yeah.
It actually shouldn't be that, because, is that right? Well, a negative might be positive, negative. Yeah, I think that is right, once you do that. And so, in factored, so let's go ahead. And what's the multiplicity of these zeros? 1, right? And so she draws out a number line chart. I'm just looking off her paper here. She puts -1, 2, and 3. And then we have odd positive, right? So that's going to be negative, positive, negative, positive. And we're less than or equal to. So we have, yeah, so she, oh, I see what you're saying. Okay, all right. Yeah, so I'm going to just kind of transliterate what she had here. So less than or equal to, so I'm just going to write this, x cubed minus 4x squared plus x plus 6 less than or equal to 0 on this interval here from -infinity to -1, is that right? Bracket, and then also on this interval too, right? Union 2, 3. Okay? Is that right now?
Yeah.
Okay, yeah. Okay? And one reason I really want to get to this section is because this level of analysis is what we're going to be doing in calculus. For those of you taking it with me next year or wherever you take calculus, if you do. So we're using that right now, number line analysis.